We're continuing on section 15.2, double integral over more general regions. This time is how to divide a region into two regions. If D is a union of, D is the union of D1 and D2, and D1 and D2 don't overlap except for the boundaries right here. The two regions are disjoint except for the boundaries. Then the integral over the entire region D is going to be equal to the integral over region D1 plus integral over region D2. So the question is, does this make sense? Yes. Just imagine you're finding the volume over the region D, and that would be the volume over region D1 plus the volume over region D2. So that makes sense. Now, example. So let's look at this region. The triangle D with vertices 1, 2, 5, 0, 3, and 3 and 4 can be divided into two different ways, giving two different iterated integral for the integral of double integral of f over region D, which D is this integral. So one way is I can basically vertically divide the region, or I can see when I divide the region, either of the triangles is going to be vertically simple regions, and then or I can divide it horizontally, and then each triangle is going to be horizontally simple region. Now we talked about vertically simple region. Here is the arrows. You can see here is horizontal simple regions, and you can see the arrows. One thing you need to do is to find the equation of the each piece of line, and then set up the integrals basically. So using the points on the graph, we found the equations of each line. This one is y equal to negative 2x plus 10. That one is y equal to x plus 1, and y equal to 5 minus x divided by 2. According to our rule, you can set up. So there's the first region, and in the first region, y is between 5 minus x divided by 2 and x plus 1. So y is between 5 minus x divided by 2 and x plus 1. And x is between 1 and 3 right here. So x is between 1 and 3. For the second region, again, the lower bound for y is the same, but upper bound is negative 2x plus 10. And then the x is between 3 and 5. Now, if you switch to the the division that we did in the to make them horizontally simple, two pieces of horizontally simple. Now x is between y minus 1 and 10 minus y divided by 2. How did I find this? By solving for x in here, I get x equal to y minus 1. And how did I get that one? By solving x, I get x is equal to 10. For x, I get 10. X is equal to 10 minus y divided by 2. And same thing here. And so basically, the lower triangle, the x value is between negative 2y plus 5 and 10 minus y. Going to the x direction, 10 minus y divided by 2, and y goes from 0 to 2. And for the other one, y goes from 0 to 4, and the lower bound is y minus 1, the upper bound is 10 minus y divided by 2. And that's how we set up the integral, both with two pieces that are vertically simple and two pieces that are horizontally simple. More questions on dividing into simple regions. Are there regions that only can be divided into, let's say, 4 simple regions? Yes. Here's an example. As you can see, we have to basically divide this into 4 simple regions. Again, there are sometimes questions that this looks like, if you look at this lower part of the white square, it looks like absolute value function moved down. Could we have used that absolute value function? Remember, absolute value function is a piecewise defined function, so it's not really elementary. So no. And so then we have to divide it into 4 pieces. And so we name them P, Q, R, S. And P, for P, for example, X is between 0 and 1, and Y is between 1 minus X and 1. And for Q, again, X is between -1 and 0, and Y is between 1 plus X and 1. And R and S, you set them all up, and then you set up 4 double integral to find the double integral of F over this region. And our region D, it's going to be double integral over P, F, D, A, in a double integral Q of F, and double integral over R of F, double integral over S of F. And for each piece, you basically the inner integral, the way we set it up is the inner integral goes from it's in the Y direction, so you find the bounds for that, and then you find the bounds for the outer integrals. And that sets up all the entire basically integral. And so, by the way, this could have been set up differently, and it could have been set up as an X direction inside, or any combination of that, as long as you break it down into 4 integral pieces, basically, 4 or more. Correct integral pieces, basically. So, subdividing regions again.